I want to be able to use these functions to answer real-world problems. So I'm going to do that. We're going to say, we will call this a real-world problem. So I'm going to start with this one. I'm going to say Sammy sits at a red light in a decent sports car. When the light turns green, Sammy steps on the gas. Let x of t represent Sammy's position x, measured in meters, a time of t seconds after the light turns green. And here's my function, x of t equals 2.3 t squared. So then I can ask a number of different questions with this. I could ask, what does x of 3 represent? So x, remember, is Sammy's position. So this part of it tells me this is representing Sammy's position. And then the argument of this function, this is the time in seconds. So this is Sammy's position after 3 seconds. That's what that one is. Now I could ask something, and to find what this is, I'm just going to say x of 3 equals 2.3 times 3 squared. 3 squared is 9, so 2.3 times 9. So 2.3 times 9 gives me 20.7. This is 20.7. X is measured in meters, so this is 20.7 meters. I could also ask, when does Sammy reach 100 meters? So this 100 meters I know is a distance. This is my x of t. So my x of t is going to be 100 meters. I'm trying to find the time, right? When? So I'm going to use my same formula. 100, I'll back up just a little bit. I'm going to use my same formula, say x of t equals 2.3 t squared. I know x of t is 100 meters, so this whole block here on the left, that's 100 meters. And that equals 2.3 times t squared. T is what I'm solving for, so I'm going to divide by 2.3. That gets rid of it over here. Divide by 2.3. That gets rid of it over here, or it divides. I can say 100 over 2.3. That's 43.5. So 43.5 here on the left equals t squared. I'm not trying to solve for t squared, I'm trying to solve for t, so I'm going to square root. That'll cancel with the squared. That means I need to square root over here, and I get t equals the square root of 43.5. So I will do that. I'm going to go the square root of 43.5, and that is 6.6 seconds. So t is 6.6 seconds. What have I solved for just now? I've solved for how long it's going to take to cover that first 100 meters. I can do one more kind of question with this, and I can say, I'm going to write the question down here at the bottom. What is represented by x of 5 minus x of 1? So now I need to do a little bit more interpreting, right? X, like we said, x was the position. X of 5 is the position at t equals 5, so the position 5 seconds after the light turns green. This one is the position at t equals 1 second. So it's how far, it's where you are 1 second after the light turns green, or where Sammy is. So the difference between these is how far, right, the difference between these, this is where you are after 5 seconds minus where you are after 1 second. And that difference must be how far you traveled how far you drove between t equals 1 second and t equals 5 seconds. So that's it. That's the whole idea. We're taking a function, we are answering a handful of different questions with it, but hopefully this is helpful to be able to see some of the things that you can come across.